Gravitation. In this module, you will learn about gravitation.
Throw up a ball. The ball decelerates while going up, comes to rest at a certain height, and then accelerates towards the ground. Have you ever wondered why the ball does not keep going up in the sky? Sir Isaac Newton was probably intrigued by the same question on seeing an apple fall on the ground.
According to Newton, the apple which had been initially at rest was accelerated towards the ground. Since this happens only under the influence of an unbalanced force, there should be some force acting on the apple. He concluded that the apple was pulled by the earth towards its center by a force called Earth's gravity. Likewise, the ball thrown upwards falls on the ground due to Earth's gravity. Besides the objects close to it, the Earth also attracts the Moon. As a result, the Moon revolves around the Earth. To understand the concept behind this, let us do an activity. Tie a stone at the end of a sling. Then, holding the other end of the sling, whirl the stone. You will observe that the stone revolves around the tip of your hand. Here, the stone is kept in its circular path by the sling. Once the sling is released, the stone will fly away tangentially to its path of revolution. Similarly, the Moon revolves around the Earth due to Earth's gravity that serves the purpose of the sling. Had there been no gravity, the Moon would have rather moved far away in space. Similarly, the Sun's gravity keeps the planets revolving around it. Starting from a speck of dust, the Earth, the Moon, the planets, the Sun to the spiral galaxy are all under the influence of gravity. This means gravity is not only on Earth but everywhere. Thus, gravitational force is a universal force. Gravitational force is also a mutual force. That is, as the Earth attracts the stone with a force, the stone also attracts the Earth with a force of equal magnitude. However, the Earth's acceleration towards the stone is negligible because it is much more massive and has a higher inertia as compared to the stone. Also, Newton gave the universal law of gravitation, which states that the gravitational force between two objects is directly proportional to the product of their masses and inversely proportional to the square of distance between them. That is, the gravitational force increases on increasing any of the masses, while it decreases on increasing the distance between the two objects. Did you ever see two pens attracting each other? No. This is because their masses are very small and thus there is a negligible gravitational force between them. Also, an astronaut floats in space as he is very far away from the Earth's gravitational influence. In this module you have learnt the force by which an object attracts every other object in the universe is called gravity or gravitation. Gravitational force is a universal and mutual force. According to the universal law of gravitation, the gravitational force between two objects is directly proportional to the product of their masses and inversely proportional to the square of distance between them. The motion of the moon around the Earth and that of the planets around the sun are due to gravitational forces.